mixed plastic waste. How do we prevent it from being incinerated or buried in a landfill? How do we make sure that it will not pollute the atmosphere and return to us as microplastics? How do we process it in line with circular economy principles? How can it be made into a sought-after product oil? The company Enespa has developed a pyrolysis system that makes the handling of plastic waste clean, sustainable and economical. And this is how our system works. The process begins with the shredding of the delivered material. As it passes through the grinder, the raw material is crushed into flakes just a few centimeters in size and then transported into the buffer box via the conveyor system. The buffer box stores the material between the loading and pre-treatment steps. It is designed to ensure continuous feed that is adapted to the process throughput. Screw systems at the bottom of the buffer box transport the material onto a weighing belt, from where it's fed into the plasticizer via a conveyor belt. In the plasticizer, the material is melted by a counter-rotating screw system and pressed into the extruder. This heats the resulting molten mass with heating elements. The material reaches a paste-like consistency before it's fed into the reactor system. The reactor system, developed by Enespa, consists of 2 pipe reactors with a special geometry and a finely controlled heat supply. This enables us to achieve an optimized yield and a solids content of less than 1%. In the reactor, the now liquid plastics are continuously heated and thermally decomposed. They now enter the gas phase. The gasified hydrocarbons are collected and fed into the condensation system at around 400 degrees Celsius. In the 2-stage spray condensation process, products with different properties are obtained. Gases unable to be condensed are washed and then made available for thermal recycling. The circulating and cooled finished product from the corresponding condensation stage is used as the spray medium. To bring about condensation, cooling water at the temperature of 55 degrees Celsius and chilled water at a temperature of 5 degrees Celsius circulates constantly through the 2 heat exchangers. Temperature, pressure and filling quantity of the condensation vessels are monitored constantly with measuring devices. As soon as the vessel has reached a certain fill level, the liquid is automatically pumped out and filled into tanks. Finished products are stored, analyzed and can then be sold. Pressure measurements, circulating pumps, valves and much more are continuously monitored and recorded by a central process control system. All measuring points are rendered in graph form as simply as possible in order to maintain an overview of the process. All relevant process parameters are recorded and stored. If a plant operator wants to run the plant at a certain capacity for a previously defined raw material composition, all necessary temperatures, conveying speeds, reactor settings and pump capacities can be found in the process control system memory. Once the recipe has been selected, the process in the system runs almost fully automatically.